All right, so problem 16, let's do 16a. Write an equation to model each graph, and we should probably write it in all forms. Okay, so what do we need to figure out? We need to figure out our stretch factor, A, that's for sure. Easiest way to start this problem would be to use the two x-intercepts given right there. I see an x-intercept at -4 and -3, which tells me that I will have a factored equation of x plus 4 times x plus 3. So what we then need to figure out is what is our stretch factor A. Because if we know that, then we are good. That's all we need. But we can't just assume it's 1. And it's kind of hard to tell what it is in this graph because of where our vertex is. That's normally how we figure it out. We'll see that in another problem. But for here, what I'm going to do is I'm going to use this point because that appears to cross the grid line. That point is at an x value of -2 and a y value of +2. I guess I'm making an assumption that each of these grid marks is going by 1. So let's make that assumption. So now what I'm going to do is I'm going to plug that point into my equation. My y value is 2 equals a times my x value is -2. So -2 plus 4 times -2 plus 3. So now I'll just simplify it. 2 equals a times what? -2 plus 4 is 4 minus 2 is +2. Times -2 plus 3 is 3 minus 2 is 1. So look at what happens. I have a multiple of 2 on the right and on the left, so we divide by 2 on both sides to be left with just 1 equals a times 1, so a has to equal 1. So that's nice. That's going to make this easier. So my equation then is just y equals x plus 4 times x plus 3. And you need to be prepared to write this in whatever form you need it in. So let's write this thing in standard form by expanding it. So y will equal x squared, x times x is x squared, plus 4 plus 3 gives me 7x, plus 4 times 3 gives me 12. So there's my standard form equation. And now we just need to complete the square. But we don't even really need to complete the square because I know y will equal, my leading coefficient is 1. So x something squared. What is that something that needs to be squared? Well, that something needs to be directly in between those two x-intercepts, that's for sure. So if it's in between -4 and -3, it is -3.5. So that needs to say plus 3.5. That's what's going to ensure the vertex is at the x value of -3.5. So we have that, but then the question is, well, what is this? What's the y value of that point? Because that's going to be our value. Well, we know it's negative, so it's going to be minus something. It looks like it's probably -0.25, but we need to verify. So why don't we plug in the x value of 3.5 into our first equation to find the y value? So y equals, I'm sorry, -3.5, the x value. So y equals -3.5 plus 4 times 3.5, -3.5 plus 3. So I'll simplify that. Y equals 4 minus 3.5 is a positive 0.5, so a 1/2, times 3 minus 3.5 is a negative 0.5, so negative 1/2. 1/2 times 1/2 is 1/4, and it's negative, so -1/4 is my value. So -1/4 will get me my vertex form equation. So typically there's going to be one form that's easy to get into. This time it was factored form, and then you'll need to use that factored form equation to help you get the other two forms as well. There you have it.